using trig to solve word problems with one right triangle. All right, so we're going to do some word problems now. I promised that in the first video, and here we are, word problem time. A few things to just reacquaint yourself with are the idea of an angle of elevation and an angle of depression. So with an angle of elevation, it's all about like if you're standing somewhere, you can like there's a horizontal, you're like looking this way, right? You're looking straight out. An angle of elevation goes from that horizontal upward. So now you're looking up this way. So here's the horizontal, but now you're looking upward. Um, and the angle at which you moved your eye upward, we call that the angle of elevation. And on the other hand, so this is going up from the horizontal, but if you go down from the horizontal like this, then we have an angle of depression. So really, these are part of like the same picture where this right here is like the angle of depression and the angle of elevations in blue. Um, and And with Alex, the problems tend to be with diagrams, so you don't have to do a ton of figuring this out on your own, but it's good to refresh on it anyway. So let's go ahead and do two problems. The angle of elevation to the top of the flagpole from a point 30 feet away is 47 degrees. Find the height of the flagpole. So let's see. The angle of elevation to the top of the flagpole from a point 30 feet away. So point 30 feet away. I'm going to go ahead and write 30 feet. There is an angle of elevation, so to the top, and that is a 47-degree angle of elevation. We want to know the height of the flagpole, so I'm going to do X there. That's what we're looking for. So in terms of the 47-degree angle, X is the opposite side, so the opposite side is X. We also know the adjacent side. The adjacent side is 30. That means we have opposite and adjacent, which is SOHCAHTOA, the TOA part. So tangent of 47 degrees is equal to the opposite side X over the adjacent side 30. You know how to solve this from here. Multiply by 30 on both sides. Boom, boom. X is equal to 30 tangent of 47 degrees. If you plug that into your calculator and round to the nearest tenth, you'll get 32.2 feet as the answer. So not so bad, right? This is kind of what you've been doing all along. Just some new words. Okay. The wording on this one's a funny because I made the wording on this one. We'll edit it a tiny bit. Example, a zip line is 250 feet long and has an angle of depression of 28 degrees from the top to the bottom. Find the vertical drop of the zip line, round your answer to the nearest tenth. I don't like how the wording of this turned out, so we're just gonna just erase that part. A zip line is 250 feet long and has an angle of depression of 28 degrees. It's still not perfectly worded, but whatever. I made this little picture in Canva and I'm really proud of it because it's really cute. Look at it. I know it doesn't look like much, but trust me, guys, it took a lot of work to do that. Okay, picture. So we have a 250-foot long zip line, 250 feet right there, and an angle of depression of 28 degrees. And we want to find the vertical drop of the zip line. So this angle of depression tends to be where people kind of get confused because the angle of depression up here is going to be up here. Angle of depression is going to be up here. And the angle of depression always goes from the horizontal downward. So oftentimes people will put the angle of depression right here, but that's not correct. The angle of depression is up here. This is 28 degrees. And we want to find the vertical drop of the zip line. So we are looking for this side over here, the vertical drop, how much drops vertically. And I'm going to call that X. Oop. So we have 250 X. And now we don't really have either of these angles. And we have two options here. We have two options. So this angle right here is a 90-degree angle, which means that this angle right here, if the entire way is 90, then we take out the 28 degrees that's right in here. We're left with a 62 degree angle. So this is 62. So that's one way we could do that. The other thing we can do, though, is a fun geometry fact. And the fun geometry fact is, hey, if you have two parallel lines, and then you have a line that traverses both of these, then you get pairs of angles that are the same. So, for instance, these two angles are the same. And they're also the same as these two angles. So all four of those angles are the same. And likewise, but less relevant, these guys here are also all the same. Just some fun geometry consequences. But what is useful for us here is the ground is parallel to this horizontal, which means we've created this situation where we're looking at this angle and that angle. So that angle's down here, this angle's up here. That's all to say that we can say that this is a 28-degree angle just by geometry. If this is 28 up here, then down here, this has to be 28. So you're able to do this either way by finding the 28-degree angle or finding the 62-degree angle. And that being said, I'm just going to work with the 62-degree angle. I have no reasoning other than that's what I want to do. So for the 62-degree angle, we have an adjacent side, which is x. We have the hypotenuse, which is 250. We're looking at adjacent and hypotenuse. Adjacent and hypotenuse, that's going to be ka. So cosine of 62 degrees is equal to adjacent over hypotenuse. If you multiply by 250 on both sides, you'll get x is equal to 250 cosine of 62 degrees. Plugging that in the calculator, you should get 117.4 feet. Keeping it in mind, if you did do it the other way, using the 28-degree angle, you would end up with sine of 28 degrees is equal to x over 250. And you would get x equal to 250 sine of 28. And that would come out to the same answer, 117.4. Okay, so there you go. A little bit about angles of elevation and angles of depression. And then in the last video, we'll talk about word problems that involve multiple triangles. I'll see you in that video. Bye.